Wait, this come up? All right, great. So yeah, I'll be talking about TypeScript. My name is Jonathan Turner. I'm the program manager on the TypeScript team. So just a kind of a brief overview of what this talk will be about. It's a, oh, fun. It's an overview about the TypeScript language. So for those of you who haven't seen it yet, we'll give an introduction to TypeScript so you can get a sense for the syntax and also some of the major features. Once we talk about that, I'll go through more of a hands-on demo because a lot of the TypeScript's value is the way that the tooling uses it and the way that we use it in Visual Studio and in other tooling. We'll talk a bit about that. And then one of the other last features of the TypeScript world is the community that's been building up around it. But first, before we talk about TypeScript, we have to talk about JavaScript. And I wanted to kind of teleport you back to when JavaScript was first made in the mid-90s. How many of you even remember using the web back then? Right? So some who are using JavaScript today, which kind of blows my mind, were born when these web pages were looking like this. So the JavaScript of this time period, when Brendan Eich first came up with it, was just to give a little bit of life to web pages. 300 lines, you make a monkey dance, there you go, you got it. When we kind of fast forward through what JavaScript has become in the community, going from that 300-line monkey dancing script language to 300,000 lines or 3 million lines when we're looking at sites like Outlook, Hotmail, or Gmail. Those are just the mail clients. A lot of applications are being built up at these large scales. So a couple of years ago in Microsoft, we had teams that were doing these large JavaScript applications coming to the JavaScript language tools team asking us, how in the world do we build these large applications safely? How do we do so in a way that works across multiple teams when we have to communicate all the interfaces, all of the contracts between these components? How do we get everyone to agree upon how objects should be modeled, and et cetera, et cetera? So that's when we did a little bit of navel gazing and said, well, it may be a good time to actually experiment with creating a language that would help with that. So this is really where TypeScript comes in. So what is TypeScript? Well, we knew fundamentally that we wanted to start with the standard JavaScript language. So TypeScript then is a superset of this standard language. We take the standard ECMAScript 5, which is the current language supported across browsers. And we're going to add to that some features that will make it scale better to these larger sizes. All of this compiles away back to plain JavaScript. And that means that we can use that plain JavaScript anywhere, any host, any OS. I mean, the popularity and ubiquity of JavaScript really come in our favor because anywhere you have JavaScript, we can now use TypeScript. And maybe a little bit of a first, but not quite a first because we have Bill Childs here who helped with other open source efforts. But really, this was an open source effort driven from the Visual Studio team trying to actually build out a language in the open, letting people comment on it, and letting us kind of drive the design before it was actually ever finalized through people's feedback. OK, so let's actually kind of drill in a little bit to see what we mean by this superset. So first off, it starts with JavaScript, meaning that I can just copy and paste JavaScript from the wild, from samples, from my existing projects, right into TypeScript. So that's great. I can just kind of ramp up quickly. This also means that the existing JavaScript libraries like jQuery and all of its fun plugins and all the various array of JavaScript libraries that are out there now are going to work on day one with TypeScript. Any of the way that they do their objects, whatever, we can just use from TypeScript because, again, TypeScript is that superset. So when we say superset, what exactly do we mean by superset? And the first thing is in the name TypeScript. So types. We have an optional static type system. It's a gradual type system, letting you kind of optionally lay in types into your project without having to go top to bottom, annotating your existing JavaScript with types to get any benefit. This optional type system, as we'll see, really plays into how tooling works, really plays into being able to build larger scale applications, communicate your requirements across your different modules. But I guess one of the key things there is that while we do all of this static type system for the tooling, we just completely erase it. So it has no overhead in the resulting JavaScript. So really, this is just a design time or development time tooling effort. And then what you get is the kind of JavaScript that you would have written by hand. It's very clean, very idiomatic. And again, this idiomatic JavaScript works across any browser, any OS. So now I've kind of talked to it, let's actually kind of pull up and look at what JavaScript or what TypeScript looks like. This is a TypeScript website, which you cannot see. Let me see if I can duplicate. Let's try that. All right. We good? Great. This is a TypeScriptlang.org. Let me actually bring you to this site. When you come here, this is a great place to actually try out TypeScript. You can go through the tutorial, and there's handbooks and whatnot to read. But I'm going to go into the playground. So the playground is, it's called Monaco. It's part of the Visual Studio Online effort. So this is actually an IDE running in the browser where you have like a pretty much a full IDE experience sitting in the browser. It happens to be written in TypeScript. We also have the TypeScript compiler that was written in TypeScript. Since it's written in TypeScript, we can compile that down to JavaScript. So both the IDE and the compiler running in JavaScript, running in the browser right now. There's nothing on the server going on. As I type, we can see that this is live updating, and it's going to compile and then output the right-hand side. OK. So just to get a sense for the TypeScript-ness of it, let's start actually adding some types in here. So if I run this example, it comes up and says, hello, object. So obviously, that's not quite right. If I go back to the original program, now that we've actually seen the error, we can probably, especially this crowd, we can probably just eyeball it immediately. But you can imagine 17 lines isn't too bad. But once we scale up to 17,000, it'd be nice to get a little bit of help. So I said that TypeScript has this gradual type system, has an optional type system. I can just kind of opt into it where it makes sense for me. So I'm going to opt into it and then add string. So basically saying this function expects a string. We can see us concatenating down here. And of course, as we do that, the tooling kind of takes over and tells us we've got an object on one side, string on the other. There's that mismatch. This is pretty straightforward. We can correct this a different way. For example, I can actually just talk about an object's type directly. So let's do that. And now I can dot into this. So where I had good errors before, now I can get accurate IntelliSense based on just having a little bit of type information. Now that I've got an object literal, let's actually kind of keep going. The next way you might refactor this is to move that object literal into an interface. So I'm going to make an interface, greeter interface. Let's call it iGreeter because it's Microsoft. And then we'll cut this over and put this in here. And this will be iGreeter. Let my IntelliSense kick on. OK, so we've now refactored that object literal up into an interface. And we've described the shape of what we expect that object to be without explicitly, can you see the cursor? Without explicitly actually saying that that object literal implements this. This is kind of showing off that this is a structural system. It's based on if you have a particular type, if you have a particular structure, and that's what that interface expects, then we say that it satisfies that interface and lets it through. The interfaces in TypeScript are actually strong enough to describe any type that you would see in JavaScript. And I would say it's one of the kind of powerful features of TypeScript itself, is this descriptive power. So here I've got the iGreeter with a message property. But I can also say that this is a function. Say this is a function that takes a number and returns a string. So anything of this type would be invocable with that single parameter, or I can dot into it. And those of you familiar with JavaScript know that I can just take a JavaScript expression and then jam a property onto that, and I have something that works like both an object and a function. And likewise, you can do the same thing with arrays. I could have an indexer and do that. So that's basically the TypeScript type system and some of that interface in a nutshell. To show some of the other features, let's pop down to classes. Here's the class syntax of TypeScript. So here we've got the constructors, we've got properties. All of this compiles down to that right-hand side, which is that idiomatic JavaScript. So you would be writing, today you would be writing that right-hand side. This class syntax actually comes, you're familiar with Luke's talk from yesterday. It actually comes from ECMAScript 6. We bring that into TypeScript of today, letting you kind of use that syntax, getting used to it. So as ES6 comes out, you'll actually have code that could easily move into it. The classes, maybe just as an interesting point, the classes here are public by default. So all of the class members you can just access without having to say explicitly that they're public. We also have inheritance. And again, we're generating that right-hand side for you so that you can have your object-oriented programming style without having to remember exactly how to tie up all your prototypes. So we talked about interfaces and classes. We also have generics. Here I show a really, really simple generic. If we have time later, I'll show you a little bit more in-depth generic. But as you can see, again, that type system kind of peels away, leaving the JavaScript code without any overhead. So we're not like reifying in the runtime. And lastly, we have a module system. So this, of course, allows you to group together classes, related functions, and interfaces. And then using fully qualified name, reach into that and get out any of the exported members. Here we declare that they're actually internal by default, and you have to export them out. So that is basically TypeScript in a nutshell. I'll skip this since this is the more attuned crowd. I think we all got that. And I actually want to show you what it's like to convert a project from JavaScript through TypeScript. Again, because the type system and the way TypeScript works is really about how it makes tooling better. And especially for those of you who have done a lot of JavaScript and have struggled with some of these, I think you'll see where some of the benefits start to pop out. So I've got an application here. Let me just go ahead and run this so we can see what this looks like. Oh, what? Maybe try it one more time. You can do it. There we go. So this is an audio file viewer. I can click around on the waves. And as I do, they draw on the canvas on the left-hand side. And we've got basically three JavaScript files that make this happen. We've got one that will load the wave files, one that displays the wave files, and this app.js that kind of ties everything together. So I'm going to start converting this over from JavaScript to TypeScript. And in order to do that, all I have to do fundamentally is, or at least to start, is to just rename JavaScript files to TypeScript files. So let me do that. So if I rename JS to TS, the first thing it says is, oh my gosh, what are you doing? You're renaming something. Are you sure this is good? And of course, we know from doing TypeScript, TypeScript being a superset, this is perfectly safe. I can just rename this. So I'll do that. And the next thing it says is, OK, we've converted your JavaScript project to a TypeScript project. Would you like to go search for type information for existing third-party JavaScript libraries? I can show you that, but just for sake of time, we'll say no for now. Just know that there is actually quite a variety of typings for these third-party JavaScript libraries. Let me rename these other two files. And then, yes, it's OK. And once more. Oh, live demos. Not many people are doing live demos. It's exciting. OK. And just to make sure that the language service has cleaned out all the old JavaScript stuff out and put all the TypeScript stuff back in, we'll go ahead and reopen this. And all right. So we're good to go. So you can see that as I open this up, we're starting to see some red squiggles. But for the moment, let's actually just ignore the squiggles. And I'm going to run it again. And assuming that the web server stands up this time, you'll see, well, we've got errors. The compiler is complaining. But I'm going to say yes anyways. So the compiler has looked through the code and said, there are things that I cannot be sure that this is correct. But because you gave me valid JavaScript, I'm just going to output that same JavaScript as you gave it to me. So we get the same thing out that we put in from just renaming those JS to TS files. OK. The next thing that we want to do is, OK, we renamed from JS to TS. And you could think about the type system in TypeScript, because it's optional, as setting a setting. At the first setting, you may have some errors. But as long as you had valid JavaScript to begin with, you're going to get that valid JavaScript back out. Now, to get the extra IntelliSense, the better error checking, we have to give the compiler a little bit of help. So what is it tripping up on? Here, we're reaching into the document, doing get element by ID, and looking at something that's specific to what's in our web page, this file select. So if we pull that up, we see, OK, file select is one of these select elements. So let's go ahead and cast what's coming out of this document element by ID. Right now, it's just a generic HTML or a general HTML element. We can be more specific. So I'm going to say this is HTML. And as I start typing, of course, the IntelliSense starts helping me out. I can say HTML select element. That sounds good. And with that, you can see the squiggles go away. We'll kind of do this. Audio file looks like that's good. And display audio, let's pull this one up. And the same thing kind of happens. We reach into the project, reach into the web page, look for wave view. And of course, that's a canvas element that we saw earlier. So let's just cast that. OK. So now we've kind of done a little bit of work just to help out the compiler get those extra bit of type specificity that it needed. It seems to have one more error. If we look at that, this thing has now, of course, caught some of the rename or the misnamed variables. So if any waves happen to be 16-bit versus or 8-bit versus 16-bit, we would have tripped over it. Now, you might have said, well, OK, I can write unit tests. I can catch things like that with unit tests. And I would say, awesome. I'm more lazy than that. It's nice to write some unit tests and then have the type system catch me from hitting things like this without having to remember to write a unit test to test every single path. Now when I change this to O, of course, I can run it again and see that now with the 8-bit wave that it just broke on, that worked correctly. And of course, all right, great. So we've been playing with that setting. We set it at 1. We just renamed our files. We kind of pulled it up a little bit. I'm going to go a little bit further and show a little bit more annotation. But to do that, let's actually just start moving the project from being a JavaScript project and having a little bit of type information to starting to use some of the other features. So here we've got this audio format. I'm going to say this is an enum of audio format. PCM equals 0, 3 equals 0, 1. And then get rid of this. And then I can also change this over. This is, in JavaScript, this would be a constructor function. But I haven't said anything about my intent about how this is going to be used. I just new it up, and then I jam a bunch of properties on it. And that's like you do in JavaScript, but it's nice to be able to be more specific. And of course, we can do that in TypeScript. So let me pull up my toolbox. And here we've got the more specific class syntax that we saw earlier. And this is compiling down to doing the constructor function for me. But now I have all of this type information and IntelliSense being fed into that. So if I hover over any of these, we can see, great, we're getting the type information. But for anything that we haven't inferred yet, we haven't annotated or inferred, we have this type any. So this is basically what the compiler is doing. It's looking through the project, looking to where it has either the type information specifically annotated or that type information is flowed in. And any place that that's not the case, it just says that this is type any. It lets any type assign to it. All right. So that's some of the class syntax. Let's continue refactoring a little bit. Let's take this class syntax and refactor it into a hierarchy. And again, this is we've seen this before. And I'm going to start using, let's say my buddy was looking at this project. He said, OK, those waves are great, but can you make them bigger? Let's amplify this up a bit. So let's add an amplify function. And this works over these audio files. Great, let's use that. And then we'll pass out. And of course, when you amplify things, always go to 11. And you'll see that we get this error. Sure enough, we're trying to convert from audio file to WAV file. And when we did our refactor to actually start supporting other file formats, we wanted to be able to amplify anything of audio file. Again, kind of generics to the rescue. So I can turn this amplify into a generic amplify. And when I do that, it's warning me, OK, you need to actually give me some constraints because I don't know anything about this type T that you're giving me. And we can say T extends audio file. So in doing that, we now have created a constraint on T, and that's giving it all of that shape that's coming from audio file. Doesn't mean that you have to have a class that extends. It's not a subclass hierarchy kind of thing. Again, it's just the structural subtyping. That structure of audio file has to be present. All right, and if we run this, with luck, we will have very amplified signal. OK. How are we doing on time? I didn't check when I started.
You have another
20, 30?
15.
15? OK, yeah. So I thought it would be fun. So that's kind of we start to see the experience of moving from JavaScript to TypeScript, getting some of the tooling experience, but really setting that setting where you want to set it. The next thing I wanted to show you was maybe some of the fun parts of how TypeScript is working underneath the surface. So first off, we have that type inference that's going on. So I've got, I can assign from right-hand side, we can infer the left-hand side. That's pretty normal. I can also take and infer from the left-hand side over to the right-hand side. So if I have a function that has a single parameter number and returns string, if I mouse over x, you can see that x is actually being inferred to number, meaning that if I dot into it here, again, we're getting that IntelliSense. So we're flowing from the parameter over. And the type inference also works from argument positions. So in a function f, we pass in a function that has that parameter. Now, these don't actually have to match in terms of name. So I could have said this is y and this is y. The parameter type showing up, or the parameter name showing up in type is just a convenience for documentation. But again, here, that type is flowing in. It knows that it's that function f that it's resolving to. And then because of that, it can fill in the type information from the argument. That's basically some of the basics of type inference. So all of that machinery is kind of going on as you're typing to kind of save you some lines. One of the probably quirkier parts of TypeScript is we're having to work with the JavaScript type system. We're having to do a couple of things that have to work with the more dynamic nature or the more like hybrid nature where things can be functions and objects. So this first example, we actually take two interfaces of the same name, and we allow that to happen. And what happens is both interfaces merge to a resulting single interface that has both members in it. The reason we do this, now you can think, OK, why in the world would you do that? If you have a class that implements an interface, and then I start jamming things onto the interface, won't it break the class? And in TypeScript, we use interfaces actually in two different ways. One way would be the traditional way of being able to implement an interface with a class and matching all the parameters and making sure that all of them line up with the interface. And the other way is to talk about the outside world. In TypeScript, we're always interacting with the JavaScript outside world. From Bjarne's talk, like C++ has to worry about interop, right? TypeScript always has to worry about the interop with the JavaScript world. So in something like jQuery, where you have a system in place on the $, and then I load a jQuery plugin, like jQuery UI, it's actually going to extend all the original objects with additional functionality. That's how the plugin system works. So it's being able to have multiple interfaces, actually adding features onto existing objects. We can model that using interfaces. And then it gets a little bit weirder. So we can do it with two interfaces. But we can actually merge declarations together, again, to try to model this dynamic nature of JavaScript. In this one, we have a function bar, and then we also have a module bar. And what this does during Cogent is it actually creates a combination of the two. That is both a function, so it can be invoked if I invoke it. See, you get to look ahead. Bar, I can invoke it with a parameter, or I can dot into it, and we can see that extent that was exported from the module side of it is also available. So it lets me create that combination. And now I'm disappointed that this is not going to be as controversial because of the talk this morning. But we also have some intentional unsoundness in TypeScript. And the reason is usability. TypeScript is not actually intended to be a sound, catch every possible type error type of language. Again, it's for the tooling. It's for actually real developers trying to get real work done, catching common errors, but then letting common patterns through as well so that you're not slowed down by the type system and a bunch of ceremony of typing things in that it should be obvious to you as the programmer are correct. So in this example, we've got two event types, mouse and keyboard. I subclass these interfaces, basically just creating new interfaces with the original my event. These are compatible. And then I have a listen to event. What I want to be able to say in TypeScript is this is an event for mice. And then I have a mouse event callback. Now, of course, this is covariance instead of contravariance. This is not technically sound. But because of the relationship between those two parameters, I can, by inspection, stare at it and say, I've got a mouse, trigger of a mouse enum on one side, and I've got a mouse callback on the other. It's perfectly correct. Please do not bug me. This should be sufficient. So again, these kind of patterns come up all the time. If we actually enforced contravariance, this would slow you down. As you can see in these alternatives, I don't know about you, but I would want to write neither of these. This is way too much ceremony. And just to maybe kind of underscore the point, while it's unsound, the unsoundness doesn't actually trip you up doing anything that would be impossible. So there's no way that something of type number actually ever could be an event. It never could have any of that additional structure. So we do err on that. So just a little bit about where TypeScript is today. So TypeScript hit 1.0 about 2 months ago. So we had been, again, kind of working with the community, building up a bunch of resources around it, making sure that the language actually satisfied how people were using it. And then when we felt it was kind of mature and ready, we released it. So it's now part of Visual Studio. You can use it as well in tools like Eclipse and WebStorm. because we give away the compiler, again, is open source, but also all the language service stuff that you saw that was driving the Visual Studio experience, that's all open source. So you can use that and move it to other editors. And of course, we support that Visual Studio, and we have a bunch of documentation. The community is one of the strong points about the language. There's a lot of helpful people in it, but there's a lot of energy as far as creating new typings around TypeScript. So I didn't show it earlier just for sake of time, but you can describe a type layer, a layer of just the interfaces, or a layer of just what the shapes of the things coming in from third-party libraries in a DTS file. And then I can add that DTS file to my project. So without modifying jQuery, without modifying Ember and these other JavaScript libraries, I can get the IntelliSense and error checking nice and cleanly against this DTS file. So the community has built up a whole bunch of these. I don't know if I've got it here. Let me show you real quick what this looks like. All right. So this is definitely typed. This is over 500 typings for all of these JavaScript libraries. So just to underscore the point, so having these available saves you that much time in trying to learn the libraries, learn the APIs. And I don't know about you guys, but my memory is terrible. So having to just be able to enter IntelliSense into it and get the JavaScript is great. Getting the APIs is great. So that's the punchline. We've got the tooling from the community and the tooling in Visual Studio and whatnot make it easier to build up these larger applications in TypeScript. Any questions?
Yes. What is it about the underlying JavaScript that compels you to allow the merging of two same name interfaces again?
So I gave kind of the example with jQuery. Imagine that just by simply loading two modules, there's something in the global namespace that's changing underneath the surface. And you have the original definition for that in your project. You've got an interface that describes that original shape. But as you're loading it, that's not the shape anymore. So being able to simply extend that, and we could have used a keyword, but we took it even shorter than that. That's right. But it's also changes what the original name, yeah. Yeah?
Maybe I'm imagining things, but I seem to remember there was some talk about doing overloading based on argument values. For example, in your unsound
yes.
You could use the value of the enum to select an overload.
Right. So the question was overload based on argument values. So currently in TypeScript, we have this thing called string-based overloads or string constant overloads. And that allows you to for example, if you're calling a function and you put the string literal bar in that position, we can, in your overload set, you can say, if I ever see the string literal bar sitting in that call, give this more specific type back out. And we do that in a couple of places in the standard library, but it's becoming more used outside of it. Because JavaScript tends to use some of that for parameterization, we do support it. Yeah.
So you mentioned earlier that like some of the class syntax is meant to be compatible or based on ECMAScript 6. What about some of the other constructs? Are those going to play well with ECMAScript 6?
Great question. So we have lambdas, and the lambdas come again from ES6. Luke's talk yesterday talked about how they do a proper this capture, and it's more of a what you would expect. And so we have that in the language. We have a module syntax. The more recent ES6 module syntax is a bit different, and we're looking at ways that we can align with that in future versions, so you can kind of support both the TypeScript style that works with Node and those guys, and also the ES6 style.
How do you deal with browser compat?
We actually kind of punt on that. So this is the questions about browser compatibility. JavaScript, I mean, think of TypeScript as like the thin layer over JavaScript. So any of the patterns that you would be doing in JavaScript, those don't go away. You tend to write in that same style. but you just get that extra bit of tooling and then just compile down from there. Yeah.
So I noticed when you did the generic constraints, you wrote T extends,
Mm-hmm.
inside the angle brackets, and that's different than what I would have expected if there were a C# pattern where you would have written where T blah blah blah.
Right.
Afterwards. And it seems like there's a few places where the TypeScript design has intentionally diverged from what C# did, and since it's the same people involved in both languages, I'm
Right.
kind of curious, does that mean that if they were to do it over again, they would say, okay, these decisions we made in C# maybe weren't the best way to do it, and now's our chance to do it right? Or does it reflect more of an intentional sort of change because TypeScript is its own separate problem space?
Right. Okay, let me see if I can repeat that. So the TypeScript design comes from a lot of the same developers or designers that C# had, but made some different choices. Would C# have been different had it been designed today? Was that basically the question? I know Mad would have to answer that one.
Yeah.
And if he feels like...
We felt that, so the choices aren't just different from C#, they're similar to Java. We felt that it was more in line with JavaScript's design to align with Java for syntax. That's how it started out. And so it was mostly that familiarity that we wanted to keep. We're not particularly wed to one way or another. We like the way we did it in C#. It's just this seemed to be a better fit for JavaScript. We weren't particularly interested in trying to make it look like C#.
We've had a lot of people say, why didn't you just make C# all over again and compile that to JavaScript? But I don't know, I think the syntax maybe kind of speaks for itself. If you come from JavaScript, being able to just opt into a couple of features where it makes sense for you is so much lighter weight than having to learn a whole new thing.
Okay, thank you very much, Jonathan.
Thank you.